briefly discuss why the sine wave methods are not ideal for locating intermittent faults on live electrical wiring. One of the sine wave methods is Frequency Domain Reflectometry, or FDR. I developed this method in 1997 to locate dead faults, opens and shorts, on dead wires on the ground. I was trying to make a handheld test system, and in fact did, for use on Navy aircraft. The FDR method sends a sine wave down, receives a sine wave back, and measures its phase by dividing the signal into a power splitter and taking it into a mixer. A mixer multiplies the incident sine wave and the reflected sine wave. When you multiply two sine waves, you get another sine wave. In this case, we also get a DC component, and the DC component is proportional to the phase shift of the reflected wave. You do this multiple times with multiple different frequencies in order to be able to locate the distance to the fault. So the Frequency Domain Reflectometry method is a sinusoidal test method that is very effective and can be used for locating hard shorts and hard opens on the ground on dead wires with no noise on the system. But for intermittent faults, it is totally inappropriate. It doesn't work. You are not able to put the sine waves on with sufficient power that you don't interfere with the aircraft and the aircraft don't interfere with you. If you made your sine waves large enough that you could receive them, you would interfere with the aircraft, and if you make them small enough you don't, the aircraft will interfere with you. So these sine wave methods, including FDR, are really not suitable for locating intermittent faults on live electrical cables. That was the main reason that I developed the SSTDR method, so that we would be able to locate the live signals with a digital code. In the case of SSTDR, we overcome the problems with the sine wave methods by sending a signal that does not interfere with the aircraft and that the aircraft does not interfere with our signal, thus enabling us to do intermittent fault location on live electrical wires.